Order of operations. We will begin by briefly reviewing the order of operations and then apply the order of operations to several examples. So you've been traditionally taught that you start by evaluating in an expression what's in parentheses. Well, sometimes parentheses could be brackets, could be squared off brackets. Sometimes you don't see parentheses, but they're implied by other grouping symbols such as radicals, absolute value symbols, and fraction bars. So even though you don't traditionally write parentheses with radicals, absolute value bars, and fraction bars, there are implied parentheses there. After parentheses, then you evaluate exponents. And after exponents, you evaluate multiplication and division in order from left to right. So multiplication and division are on the same level. You do not go through and do all of the multiplication first and then the division. Instead, you start at the left of the expression and go from left to right and evaluate the multiplication and division as you encounter them in order from left to right. Similarly, after multiplication and division, you evaluate addition and subtraction in order from left to right. So it is really essential that you remember that addition and subtraction are also on the same level. You do not go through and do all the addition first and then cycle back and do the subtraction. Instead, you start at the left of the expression and go from left to right and evaluate the addition and subtraction operations in the order in which you encounter them. So these beginning letters, the P, E, M, D, A, S, is where the acronym PEMDAS comes from, which you've been taught before. And we will continue to use PEMDAS, but what is really, really essential is that you remember that when you're evaluating multiplication and division, you do it in order that those two operations are at the same level and you evaluate them in order from left to right. Similarly, addition and subtraction are at the same level and need to be evaluated in order from left to right. Okay, so example 1. Here we have -3 minus 4 times, and then in squared off brackets we have -3 minus 4 times, and in parentheses, -3 minus 4. So traditionally you've been taught, okay, we want to evaluate what's in the parentheses first, but we have two types of grouping symbols here. We have curved parentheses and we have squared off brackets. And we need to start at the innermost ones. So we will start here with the innermost curved parentheses and we will subtract -3 minus 4. Okay, so I'm only going to change that here. I'm going to keep everything else in the expression the same. So I still have -3 minus 4, squared off brackets, -3 minus 4, and then in parentheses, -3 minus 4 is -7. So that's where our -7 came from, and that was the first step. So now those parentheses around the -7 are just showing that we're going to multiply -4 times -7. There's nothing further to evaluate or simplify within those parentheses. So we're going to go out to the squared off brackets and we will evaluate what's in the squared off brackets. Well, we don't have any exponents, but we do have multiplication right here. So we will, in this step, multiply -4 times -7. I'm going to keep everything else in this expression the same. So -3 minus 4, squared off brackets, -3, and then -4 times -7 gives us this positive 28. So I have -3 plus 28 in the squared off brackets. Okay, so we still need to continue evaluating what's in the squared off brackets, and we will, in this step, add -3 plus 28. I will keep everything else in the expression the same. So -3 minus 4 times in the squared off brackets. Inside the squared off brackets, we have -3 plus 28. which is our 25. So that's where this 25 came from. Okay, so now we've got the squared off brackets, but it's just showing that we're multiplying negative 4 times 25. So next, we don't have any exponents, but we do have multiplication. So next, we will multiply negative 4 times 25. Now we could also have thought about this as negative 3 plus negative 4 times 25. Negative 3 minus 4 times 25. I'm going to choose to think of it as plus the negative 4 times 25, which is why I'm multiplying negative 4 times 25. I'm going to keep the negative 3 the same, so I have negative 3 minus 100. And then I'm going to subtract the negative 3 minus 100. And the 100 was because we did negative 4 times 25, which is where we got the negative 100. So now, finally, subtracting negative 3 minus 100, we get negative 103. And that is our final answer here for this example. Okay, example 2. Example 2, it says simplify 1 plus, and then we have a very large looking fraction where we have in the numerator 7 times 5 minus 8 times 4, and in the denominator we have 9 minus 6. Okay, so this fraction, this very complicated looking fraction, we have implied parentheses around the whole numerator and around the whole denominator. So in the numerator, we don't have any exponents, but we do have two sets of multiplication. And we will multiply 7 times 5 and 8 times 4. So first step, multiply 7 times 5, multiply 8 times 4. And in the denominator, we just have simple subtraction, and we will subtract 9 minus 6. So I will keep the 1 plus part the same. 7 times 5 is 35, so that's where 35 came from. 8, I still have this minus, still right there. And then 8 times 4 is 32. That's where my 32 came from. 9 minus 6 gave me my 3 in the denominator. So we have 1 plus 35 minus 32 all over 3. Okay, again, we still have implied parentheses in the numerator. So now we will simplify what's in those implied parentheses, and we will subtract 35 minus 32. I will keep the 1 plus, and then 35 minus 32 gives me 3. In my denominator, I already have 3. Okay, so now, remember that fraction bar means we will divide. So it's like 1 plus 3 divided by 3. So division comes before addition. So we will evaluate 3 divided by 3, or divide 3 divided by 3, which is 1. So now we have 1 plus 1. In our final step, we will do that final addition of adding 1 plus 1, and our final answer here is 2. So one final example, our third example. Simplify, and we have this very complicated looking fraction where we have 24 divided by 4 plus 3 times the absolute value of negative 2 minus 1. So these vertical lines right here are absolute value bars. Remember, absolute value is the distance that a number is from 0. And in the denominator, I have 2 minus 3 cubed plus 10 squared, or 2 minus 3 to the third power plus 10 to the second power. Okay, so again, we have implied parentheses around the whole numerator. And inside the absolute value bars, we have another set of implied parentheses and implied parentheses in the denominator. So we need to go to the innermost set of parentheses. And here I'm just going to do one step at a time. I probably could do one in the numerator and one in the denominator, but I want you to be able to follow what I'm doing. So I'm just going to do one evaluation here. And we are going to subtract in the absolute value bars the negative 2 minus 1. Everything else will stay the same for this problem right now. So in my numerator, I now have 24 divided by 4 plus 3 times the absolute value, and then negative 2 minus 1 gave me this negative 3 that I have inside the absolute value bars. My denominator I kept exactly the same. So I have 2 minus 3 cubed plus 10 squared. Okay, so again, we still have implied parentheses. I'm looking at my numerator, and I have the implied parentheses that come with the absolute value bars. We need to take the absolute value of that negative 3. Remember, I just reminded you that absolute value is the distance a number is from 0. How far is negative 3 from 0? Negative 3 is 3 units from 0, so we will take the absolute value of negative 3, and we will get positive 3. And that is the only thing I'm changing in this problem. Everything else will stay the same. So 24 divided by 4 plus 3 times positive 3, because that was the absolute value of negative 3. And my denominator stayed the same, 2 minus 3 cubed plus 10 squared. Okay, we still have implied parentheses in the whole numerator and in the whole denominator. We don't have anything to evaluate within that parentheses with the 3. We don't have exponents in the numerator. We do in the denominator. So let's look at those exponents in the denominator. I have 3 cubed. I have 10 squared. So I am just going to evaluate the exponents right now so you can follow what I'm doing. We will evaluate 3 cubed and we will evaluate 10 squared. So my numerator will stay the same, 24 divided by 4 plus 3 times 3. My denominator will be 2 minus, and then 3 cubed gives us 27. Now it is important to note that it is not negative 3 cubed. There's no parentheses that include the negative sign. It is just the 3 that is the base. So only 3 is cubed. That's why I still have the minus sign from the original problem. And then 3 cubed was 27. Plus 10 squared gave me the 100. We still have implied parentheses in the whole numerator and in the whole denominator. We've evaluated exponents. So next, remember, is multiplication and division in order from left to right. So we have division, 24 divided by 4. We have multiplication, 3 times 3. And I circled them in the order that I encountered them from left to right. So in this next step, we will divide 24 divided by 4 and then multiply 3 times 3. And I'm going to keep everything else the same in this problem so far. So now 24 divided by 4 gives us our 6. And I still have plus in between those 2 circles that I drew around 24 divided by 4 and 3 times 3. And then 3 times 3 gives me 9. My denominator I kept exactly the same. So I have 2 minus 27 plus 100. We still have implied parentheses around the whole numerator and the whole denominator. So now we can work on evaluating addition and subtraction in order from left to right. So in my numerator, I'm going to add 6 plus 9. And in my denominator, I'm going to start at the left and subtract 2 minus 27. Okay, going to the next slide. 6 plus 9 gives me my 15. And we have negative 25, which was the result of that subtraction, plus 100. We still have implied parentheses in the denominator. We're going to do that addition in the denominator. So we will add negative 25 plus 100. I'm going to keep the 15 in the numerator. 15 over negative 25 plus 100 gives me my 75 in the denominator. Okay, now remember, fraction bar is division. So we could think of it as 15 divided by 75, but because the numerator is less than the denominator, we will get a fraction. So let's simplify our fraction. So that will be our step here. So what we need to do is find the greatest common factor of the numerator, the greatest common factor of the denominator. So what is the greatest common factor of 15 and 75? That is 15. And we will divide the numerator by 15 and the denominator by 15. 15 divided by 15 gives me 1. 75 divided by 15 gives me 5. So my simplified fraction is 1/5. And that is my final answer to this problem.